Stan Gibilisco here, proprietor and operator of amateur radio station W1, GV Whiskey 1, Good Vibrations. A viewer recently asked a rather complicated question, but the gist of it is, how important is resonance to the proper operation of an antenna, particularly with a radio transceiver, transmitter, designed for a 50 ohm purely resistive output? Does the antenna itself have to be resonant or not? Well, the answer is no. The antenna itself does not have to be resonant. What does have to be resonant is what the radio sees: 50 ohm purely resistive non-reactive impedance, that is a resonance of 50 ohms. By non-reactive, I mean there's no capacitive reactance, no inductive reactance, and it occurs at a single well-defined frequency. Of course, you can have 50 ohms of pure resistance without any reactance if you use a 50 ohm non-reactive resistor like a dummy load, but that's not resonance. Resonance occurs at a single frequency, and you obtain resonance either by feeding an antenna like this. In this particular case, the feed point impedance would be about 72 ohms, so you would feed it with 72 ohm coaxial cable and endure a 1.4 or 1.5 to 1 mismatch at the radio. But here we have an example of a resonant antenna, 1/2 wavelength long, fed with, which has a 73 or 72 ohm center resistive impedance, fed with 450 ohm ladder lines. So you have a pretty high standing wave ratio here, and this is no longer a resonant system once you include this line with this length at this impedance, at any length with this impedance. So you need a transmatch to tune out the reactance and then adjust the remaining pure resistance to 50 ohms for the radio. So the radio does indeed see a resonant system. The antenna alone is a resonant antenna, but this part, beyond the transmatch, is not resonant. And that is where the problem appears to have arisen in the understanding of how important is resonance. This would work very well as an antenna for ham radio applications if the line isn't too long, because 450 ohm ladder line has a very low loss per unit length, practically negligible, almost regardless of how high the standing wave ratio gets. Another misconception, though, was that what happens to the electromagnetic field as it travels along this line from the transmatch to the antenna and ultimately outward as radio waves over the air. A lot of it will bounce back off the antenna to the transmatch, and the viewer or reader was assuming that all of that energy would be absorbed by the transmatch. So once this energy gets reflected back, it never comes back. It's lost forever. Well, if that were the case, transmatches would get awfully hot at high power levels in ham radio applications, but you don't see that. What actually happens is that all of the power or energy that comes back down along this line is reflected back again towards the antenna, where again most of it, a lot of it is radiated as electromagnetic waves, but some of it comes back yet again and arrives at the transmatch yet again in diminished form, whereupon it is all reflected back again, and this occurs quite a number of times. Theoretically, an infinite number of times in a damped wave sort of fashion, so that it becomes weaker and weaker and weaker very rapidly, because electromagnetic fields along 450 ohm ladder line like this travel at about 95% of the speed of light. You don't hear a ringing when you send da 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 da, because although there is some, it disappears too quickly for you to notice. It disappears even though it may have reflected hundreds or thousands of times back and forth along this line before it got to be of negligible strength. So this is a resonant antenna system if properly tuned, and this all by itself, the antenna, is a resonant antenna. It's just that the impedance is different. 73 ohms or so here, 50 ohms here at the radio. But the transmatch isn't changing this 73 ohms to 50 ohms. It's doing a lot more work than that. It's changing a very complicated reactance-laden impedance to something, somehow, in some way, to get it to be a 50 ohm resonance. So the radio sees a resonant 50 ohm antenna. The antenna itself is a resonant antenna, but the whole system here, beyond the transmatch, is anything but resonant. So, voila! The magician at work, the transmatch, which indeed is a sort of magician in ham radio applications. I hope that helps to clear things up and doesn't make things even more confusing, but this is a complicated subject, and I advised the viewer to consult the ARRL antenna book for more information, and it's a gradual learning and understanding process. I apologize for the ragged look of this video, but I couldn't get my computer down here in the nerd cave to work with Corel Draw. It seems to require that program be reinstalled, and I'm not exactly sure where well, yeah, I know where the CD is, but I'm too lazy to do that today. So hopefully this is good enough for you to see, and hopefully my explanation is good enough for you to understand, at least to some extent. Resonance is important in the overall sense, but in the smaller sense, not necessarily. Stan Jubilisco, W1GV, saying 73, and no matter what the antenna type, impedance, resonance characteristics, or anything in my native fist, shall always translate to da-da-da-da-da-da.